So you could do that one of two ways. You could just subtract b from a or a from b, take the absolute value. That gives you the distance on a number line. The distance on a coordinate plane, remember coordinate plane is like an xy axis. Okay, how to find the distance on 2 points? We can use this formula called the distance formula, okay? It looks pretty complicated, right? But all we're doing here is we're taking the square root of all of this, which it says the second x coordinate minus the first x coordinate squared, plus the second y coordinate minus the first y coordinate squared. Okay. Now this is between 2 points. Okay, we just plug those points into this formula and simplify. This is called the distance formula. Now the reason we have to use the distance formula, we can't just count like in a number line, is because not all the lines are exactly horizontal or exactly vertical, right? We want to find the distance of the line when it's not horizontal or vertical in a coordinate plane. Okay, we do this with the distance formula. So on this number line, pretty straightforward, find QR. How long is QR? Well, one thing you can do is just start here, and it's 1, 2, it's 3 units, right? Just by counting. Let's say if it was huge and I couldn't count, all I'd have to do is take either -6 minus -3, or it doesn't matter because you're using absolute value, -3 minus -6. That becomes a plus. -6 plus 3 is -3. So that's 3. That becomes a plus. That's +3, which is also 3. So if you can count them on a number line, that's how long they are. Okay. Or you just subtract the 2 coordinates from each other, or the 2 numbers from each other, and take the absolute value. Okay. What's that? Yep. It's all right. Okay. Yeah. So from a to x here, okay, again, one thing I can do is count. Let's say I didn't just count over. It's a little bit longer. I could take -5 minus 3, take the absolute value of that. We'll simplify that. That's -8. Absolute value makes it positive. So AX is 8 units long. Okay. So I just took the absolute value of those, the difference of those 2 numbers. What's that? Yeah, if you can do subtraction, you can find distance. Okay. That's distance on a number line. Now, next is distance on a coordinate plane. Okay. So see, we can't use just count here, because if I want to find EF, right, that's this line here, I can't just count over units because it's a slanted line, right? I can't say 1, 2, 3, 4. But there's 2 ways that I can find how long this is. We're going to do both ways. And you can choose whatever way you want to on, like if this was a quiz question or a test question, which it very likely will be. Okay. One way is to use the Pythagorean theorem. That's to make it a right triangle. We'll talk about that. And find that distance using Pythagorean theorem. The other way is the distance formula, which we just talked about. Okay. So first let's look at the Pythagorean theorem way. The Pythagorean theorem says if you make this a right triangle, which we just drew down that line and made point D, it's a right triangle. You know Pythagorean theorem says if you take one leg squared plus another leg squared, it's equal to the hypotenuse squared. The hypotenuse is the side opposite that 90-degree angle, right? So I know from E to D, that looks like it's 1, 2 units. From D to F, looks like it's 1, 2, 3, 4, 5, 6, 7 units. And I want to find what is E to F. So if I take this squared plus this squared, it's equal to x squared. 2 squared plus 7 squared is equal to x squared. That's what Pythagorean theorem says. If you take a leg squared plus a leg squared, it's equal to the longest side squared in a right triangle. Well, 2 squared is 4. 7 squared is 49. And adding those together gives you 53. Okay. Again, though, I have x squared is 53. I want just x is 53. So how can I get rid of that squared? Yeah, square root both sides. Now remember, normally when you take the square root of both sides, you have to write a plus minus out in front of here because it's a positive and negative answer. You don't have to do that here because we're talking about distance. Distance is never negative. So just take the square root of both sides. Those kind of cancel each other, and I get square root of 53 is x. That's the distance. Now 53 doesn't have a square root. If you punch it in your calculator, it'd probably be like something like 7.1 or 2 or something like that. Okay, is how long this unit is. But you can just leave it as a square root. Okay, no reason to round it off as a decimal. So that's method 1 using Pythagorean theorem. We made that a right triangle. Okay, we use Pythagorean theorem. Let's talk about method 2 using that distance formula, okay, which we just solved. The distance formula says this. the distance from one point to another is equal to the square root of the difference of the x's and difference of the y's. Now, remember these things down here are subscripts, okay? They have no mathematical meaning. They're not like squared, okay? These are just a way to tell different x variables apart, okay? So this is saying the second x coordinate, so it doesn't matter which one you choose as the first group and the second group, but let's say I choose this as the second one because it comes second. That's the second x coordinate. I'm going to plug it in there. That's the first x coordinate. I'm going to plug it in there. That's the second y coordinate. Goes there. First y coordinate. Go there. I'm going to plug those in and start simplifying. Okay, we'll do that when we come back from lunch. Have a good lunch. So I have these x and y as coordinates. I need to plug them into the second x and the second y, or the second x and the first x. So let's treat this as the second x. That will be 3 minus negative 4. So plug that in. Squared plus. So if this is the second x, this has to be the second y. Negative 1 minus.
Why is the line here 3?
What's that?
Oh, never mind. I know what it is.
So double negative here becomes a plus. That's a 7. 7 squared will be 49. Negative 1 minus 1 is negative 2. Negative 2 in parentheses squared, that's like negative 2 times negative 2, which is positive 4. Add those together. I get square root of 53, just like I had before. Okay. So you can use distance formula or Pythagorean theorem to find the distance of a line segment on a coordinate plane. Okay, whatever one you prefer. If it's easier for you, makes sense to you, use that one. Okay? So in this case, let's just say we're going to use 1. If you want to use Pythagorean theorem, you can. Okay, you would draw a line down to here and over to make a right triangle. But if you used distance formula, I would take the second x, which is 1, minus the first x, which is negative 3, plus the second y minus the first y. 2 minus 4 squared, I'm kind of running out of room. Yes.
Like in the first parentheses.
Uh-huh.
Isn't it still the same thing? Like when you there's a negative, you subtract 3, and actually still turn into like 1 plus 3.
Right. At this point right here, right. So this double negative right here, yes, that becomes a plus, which makes that 4 squared plus. In this case, it's kind of hard to read. That's 2 minus 4, right? 2 minus 4. Negative 2 squared. Okay. So that's going to look like this. Well, that's 16 plus 4, which is 20. For those of you that remember how to simplify square roots, you know, to pull out a perfect square, you don't have to do that right now. You can just leave it as square root of 20 instead of making it 2 square root of 5. Okay. Just leaving it as a square root is fine for me. Questions on that? Okay, so that's how we find the distance on a coordinate plane. The last, second to last thing is midpoints. Okay, how when given a line segment, how do you find where the midpoint of that line segment is? Well, in a number line, pretty simple. We just take the average of those two numbers. Okay, I add them both together, divide by 2. Just like if you were taking the average of 3 things, you add all 3 together, divide by 3. I just take the average of those two numbers and divide by 2. So if this happened to be 2, this happened to be 6, I would add 2 and 6 together, divide by 2. That's 8 divided by 2, which is 4. The midpoint would be at 4. Okay. On a coordinate plane, it's the exact same thing, except you just have to do it once for the average of the x coordinates and once for the average of the y coordinates. Okay. I will take the x's, add them together, divide by 2. That's going to be the midpoint of my x coordinate. Okay. Take the y's, add them together. That's going to be the coordinate for the midpoint of the y. Okay. So if you can take averages here, you can find midpoints. For example, these two on a number line. Okay. Let's say I had j and k were on a number line. One was all the way to the left at negative 12. One was all the way to the right at 16. I just need to take the average of these two numbers. I need to take negative 12 plus 16 and divide that by 2. Okay. Well, negative 12 plus 16 is positive 4, and positive 4 divided by 2. The midpoint between negative 12 and 16 is at 2. Because if I went to the left 14, I would go to negative 12. If I went to the right 14, I would end at 16. Okay? So that's how we find midpoint on a number line. You just take the average of those two numbers. Okay? Add them together, divide by 2. Same thing here. We won't go through this one. I would add 7 and negative 15 together. Okay? If I have $7 and I take away $15, I'm in debt $8. Okay? Then I divide that by 2, and I would get negative 4. Now, if they're on an XY axis, so if I told you to plot the point 8, negative 6, and plot the point negative 14, 12, you're going to go and plot those, connect them. Where's the midpoint of those two at? Right? It's not easy to tell by just looking at it. All I have to do is take the average of the x's and the average of the y's. That's my midpoint. Okay? So if I take the x's, 8 and negative 14, add those together, divide that by 2. That's going to be my x-coordinate. Well, 8 plus negative 14 is negative 6. Divide that by 2, negative 3. So the x-coordinate of my midpoint is going to be negative 3. The y-coordinate, I just have to take the average of the y's, negative 6 and 12. Negative 6 plus 12, divide that by 2. Okay, positive 6. That divided by 2 is 3. So the midpoint between those 2 points is at negative 3, 3. Took the average of the x's. Took the average of the y's. Let's look at one more of these. If I have at negative 2, 3, and negative 8, negative 9, those are my 2 points. I want to find the midpoint of those 2 points. Okay. I want to find the midpoint of those 2 points. Remember, midpoint formula says if you take the average of the x's and the average of the y's, that's going to be your 2 coordinates. Okay. So my 2 x points are negative 2 and negative 8. So I'll take negative 2 plus negative 8, divide that by 2. My 2 y coordinates are 3 and negative 9. So I'll add those together, divide that by 2. Well, if I'm in the whole $2, I'm in the whole $8 more. I'm in debt $10. I have $3. I add a debt of $9. So I'm negative 6. Well, now just simplify those. Negative 10 divided by 2 is a negative 5, and there's a negative 3. So the coordinates of the midpoint are negative 5, negative 3. Now, sometimes, like let's say this number was a negative 11, you can't divide by 2, that's okay, because it's not always going to be at the intersection of a xy axis whole number coordinates. It might be a decimal here. That's okay. If this was if this was negative 5, you would get negative 2.5 here. Okay, that's okay if it's not a whole number, or if it's not an integer. Okay. Questions there? That's the last one. That's for finding midpoints between 2 coordinates.
I always subtracted the x1.
No, always add here. Always add here. Yeah. All right. Okay. So the other way, this is using the exact same formula, but what happens if I only gave you one endpoint and I gave you the midpoint, and I told you to find the other endpoint? Okay. So like the last 2 problems, I gave you both endpoints, find the middle. This time I gave you the middle and one of the endpoints, find the other endpoints. Okay. Well, just to recall, remember, I take the average of the x's, divide that by 2. Whatever that is equal to the x-coordinate of the midpoint. I'm going to call that x sub m, just for the x-coordinate of the midpoint. This is the x-coordinate of one endpoint, the x-coordinate of another endpoint. This is the x-coordinate of the midpoint, right? Because whatever this number is, it's the x-coordinate of the midpoint. We just did that. Well, the same thing with the y's. If I take the y-coordinate of the first one plus the y-coordinate of the second one, divide that by 2, that's equal to the y-coordinate of the midpoint. Okay? And again, the subscripts are just a way for me to determine which one I'm talking about, which y value I'm talking about, which x value. Okay. So now in these 2 equations, I'm just going to plug in what it gave me. Okay? It gave me this is the midpoint. So where am I going to plug in this x value? Into one of the endpoints or to this midpoint here? It's the midpoint, right? So it needs to go for the x value of the midpoint. Okay? It needs to go right here. This is one of the endpoints. F is one of the endpoints. So this x value let's say, needs to go for x1 or x sub 1. Okay? And I can need to find x sub 2. So let's do that. I'm going to plug in the x value of one endpoint. Plus I'm missing the other endpoint, so I'll leave that. And that's whatever this number is, has got to be divided by 2 has got to be equal to -6, the x-coordinate of the midpoint. So we need to solve this equation for x sub 2. Well, I need to get rid of this division by 2. What's the opposite of dividing something by 2? Multiplying. So if I multiply all of this by 2, those 2's will cancel. That means I need to multiply this side by 2. So I'm left with -5 plus x sub 2 equals -12.
Why
Well,
didn't you put -3?
what's that?
Why didn't you put -3 in the x?
Why did I put -3 in the x?
In the x2.
This part?
Yeah.
Because I don't know what the other endpoint is. Because this is the midpoint, not the other endpoint. This is like the answer to the problem we were just doing before. And I want you to give me the other endpoint. Okay? And well, this -3, since it's an endpoint, we'll go for the y value. Because remember, it's always xy. Okay? Well, to solve this for x sub 2, I need to get rid of this -5. Add 5 to both. So I get the second endpoint is at -7. Okay? So this time, it was kind of like I gave you the answer to this problem. Give me the other portion of the question. Well, the x-coordinate is -7. Now I need to do the same thing for y. It gave me one endpoint at -3, so I'm going to plug that in. I don't know the other endpoint. I'll call that y sub 2. But I do know the y value of the midpoint. That's 4. And then I solve this just like I did the other one. Get rid of that division by 2. So I'll multiply both sides of this by 2. Those cancel. I get -3 plus y sub 2 is 8. I need to move that -3 the other side. So I'll add. So I'm left with y sub 2 is 11. So the coordinates of the other endpoint are at -7, 11. Okay. So instead of finding the midpoint, I had you find the other endpoint. You understand the difference between those? Yeah. That if you're given both endpoints, just take the average of those, and it gives you the midpoint. If you're given the midpoint, okay, you need to find out what other number goes here, okay, by solving these equations. All right, so what questions do we have on that? Yes. Last thing we'll talk about in this section is if you're given the midpoint, how do you find a variable? So I know this problem tells me Q is the midpoint here. So I know from P to Q has to be the same as from Q to R, right? So if I put those little tick marks there, it means this piece is the same as this piece, right? Because it tells me Q is the middle, okay? And it says find what PR is. Find this whole thing. So I need to find out what X is, because once I have X, I'll just plug it in there. Right? Well, if these two pieces are the same, and this one's 6 minus 3X, what's this one got to be? 6 minus 3X. Okay? So I'll go ahead and label it. So I can do one of two things here. I can either say this piece plus this piece is equal to this piece, which is true, and I could do some algebra and solve for X. But I also, instead of just adding all those, I also know 2 times 6 minus 3x is equal to the whole thing, 14x plus 2, right? I just multiplied this by 2 because there's 2 of them here. The other way you could have done it is you could have said 6 minus 3x plus 6 minus 3x equals 14x plus 2. If you want to solve it this way, you'll get the same thing. The reason I did this because it looks shorter, right? Okay. So if you want to just add this piece to this piece, it's equal to the whole piece, but you can also just multiply this piece by 2. It's the same thing. Okay. So let's say we go ahead and finish that. We need to distribute to get rid of those parentheses. Distribute. Distribute. 12 minus 6x. Right side stayed the same. We'll get those x's together on the right side of the equal sign. In this case, let's say we add that 6x over. So I'm left with 12 here, I'm left with 20x here, I'm left with 2 here. Again, I'm trying to solve for x, so I need to move that positive 2 over the other side so I can get x by itself. That leaves me with 10 is equal to 20x. Undo that multiplication by 20. So x is equal to That simplifies to 1/2, right? 10 over 20 is 1/2. So that found the variable, but the question asked for what is PR? So what is from here to here? Well, now that I have x, I'll just plug it into there. 14 times 1/2 is 7. Add another 2. How much is PR? 9. So just be sure in these questions that you know what it's asking. Sometimes it just asks you to solve for the variable. Other times it asks you, how long is this piece? How long is this piece? Once you have the variable, you can just plug it back into whatever one you need. Okay. So the answer is 9 because PR from here to here was 14x plus 2. So when I plug in a half back there, 14, half of 14 is 7. Add another 2 is 9. Okay. So if this piece was 9, how much would this piece be? They both got to be the same and add up to 9, so what's half of 9? 4.5, right? Because if I plug this in, if I plugged in a half here, that would give me 3 times a half, which is 1.5. And 6 minus a half is 4.5. Because I know these are the same.
You don't put a half in for x?
Yeah, you do. That's what I did here. Because I'm trying to find what PR is. And PR is from here to here.
You put 7.
Well, I put a half in here, and then 14 times a half is 7.
Oh.
You see what I'm saying? Yeah, got it. Okay. All right, let's look at one more.
How did you get
Oh, go back.
Sorry.
How did I get 7?
9.
Oh, 9. So the question asks what is PR, so let me highlight it here. PR is this whole piece right here, right? So now that I know x is a half, if I plug in a half right here, half of 14 is 7, plus another 2 gave me 9. That makes sense? Yeah, good question. Yeah, if you can't figure out why I wrote something, please ask, because I'm wrong a lot. Okay. Other questions? All right. This one is going to be the exact same. We won't go through all of this one, okay? Because if this piece is 2a minus 1, and this is the midpoint, that means this piece has to be 2a minus 1. So it would be the exact same problem. I would add those two pieces together, or just multiply by 2, and it equals the whole piece. Okay? We won't go over that one because there's a couple things I want to get to today other than that. So your previous homework, let's get that out and go over a couple questions there.